When you have completed these steps, you need to move that generate file tab, generate files. Same, you need to follow that step, nanodecals, analysis. In the device tab, right electrode. Now you need to select that right electrode. And then same band structure you can select, charge you can select, and again you can click generate file. Same for the simulator nanodecal analysis. Now it is the same device. You can select in here the charge, transmission, IV curve, like that properties, conductance, density of states. You can select that any properties, and we are selecting that simple. And in here the projected atom, you can select the atom. Transmissions, for the transmission generally nanodecal prefer for the 100 space grids, and IV it will be same conductance. You can choose density. For the transmission you can choose that value. We are follow that nanodecal tutorials. Please select that value. Here you can also select that density of state for the atom. It is already selected. Transmission, IV curve, conductance. Please follow that step and click the generate file tab. BK Patnaik sir is asking, repeat the spin part, specifically is plane of selecting hydrogen atom rather than the carbon in collinear spin option. Sir, we are not selecting that any special elements like spin parts, like you are seeing. You can check that XCF input files. Only we are selecting for the spin types. It's just for the click, not to select carbon or hydrogen. You only select that collinear spin. It is automatically selected. It is a editable. If you want to edit something, you can edit. Okay. Like for the same, you can see for the spin polarization, we are calculating properties. It automatically selected. It just input files. After that, you can run that file. In our previous session, we have already told you about that. First, we need to run the left electrode, then right electrode, then device. So follow the same procedure. Run left electrode. You can simply run. We need to import in here the some files for the nanodecals. Run that XCF file for the left electrode. Same for the band structure. Same for the charge input files. Now we can run that right electrode XCF file. Same for that band structure files and charge input files. You can see in the queue form, left electrode, right electrode, they are still running. Calculation has been started. Like this, you can check. Number of the atoms in here you can check. It's have 50 atoms, therefore it will take some time. We are just considering one of the simple structures because it will take more time if you are select number of the atom more. Therefore, we have already run that project. You can zoom like this structure. It will take some times in your systems, so we can't waste much time in here. We directly go to the same projects. Like you can see, we have stored the same first steps. After that, we have created the another structures. Then we move toward the device parts. You can see that the same value we have increased in here the buffer. The so scattering regions are increased, and after that, same left electrode. You can see that XCF files because it running that the same XCF files. You can check, and then band structures. Same for the right electrode. It is a script and XCF file for the right electrode. And it is XCF input file for the device. In here we are choosing no spin. I am choosing collinear spin. For the magnetic properties or any properties we can also calculate at the same. We just calculated in here the IV curve. And then you can check the band structures. For the left electrode, you can see spin up and spin down. Charge file will be open in the MATLAB. So I will also show today the MATLAB, how we can import, how we can see it for the same, because right and left electrode is same except files. And in here you can check the device transmissions, that result that come in here. We have already told how we can import, how can exports. So in our previous session we have already discussed about this type of structures. So firstly we need to see that IV curve in the MATLAB. Then I will told you about that another steps, like how we can do doping and replace the atoms and different properties. So please open the MATLAB. Before opening the MATLAB, if anybody want to ask, please ask. I think that device structures that we are doing in here, it have completed in your systems. So result will take times. So now I'm going to open the MATLAB files like we are working. We have already imported, but you can directly open the MATLAB online and browse the folder, and where your project are imported, like we have imported in the home tab. If anybody have imported the PC or anything, you can directly select your projects and please import in the MATLAB. Like we have project in here, like you can see zigzag graphene, yeah, any projects. So just select that folder and you can directly import your projects. Follow the same step: home, device studio, and imports your projects where they are stored, like this. Please, if anybody have confusion related to this, please ask. Because some of the results we can see in the MATLAB, they have some dependency. So you can open that MATLAB online also. But it is still running, I think, in your systems, and results are not completed. So I'm just giving the hints how you can see that results. Like first you can click the calculated results, current voltage. You can click the data like this, and V1, I1, V2, I2 you can see in here. If you don't want to see in here, you can directly see in here. Currents, it for the different value. Voltage, we have stored that value. One of the important file that I'm going to show, you can see V1, I1, spin decompose, V2, I2. We are just calculated for the 0 and 0.2 like this. So it is just for the simple value. I also tell how we can do biasing and calculate different biasing voltage. It just for the simple value. You can collect these value, and in the MATLAB you need to define this type of script. For the VI curve, we need to follow that procedure. Firstly, you need to create the project in the device studio, and then you need to import in the MATLAB. After that, collect the data from the current voltage mat files and XML files you can also see, and then you need to create that type of strict or script, and after that you can click the run. Like this, you can find that VI curve of the zigzag graphene, yeah, any device or any structure. It is just simple example for the simple structures, but if you want to create different structures and different biasing voltage, I will also told you how we can move the next step, but it's simple for the VI curve. So if anybody want to ask related to this VI curve or anything, please ask. So okay, we need to move that the same. Like you can see, some of the results are coming in here and the file are completed like this same. Some of the file are still running conditions. After the running that files, you need to run that device file also, like XCF inputs, write electrode files. So click the run files, charge input files, transmission, IV curve, conductance, and density of states. Okay. Now it is a simple voltage, but if you want to move with different voltage, so simply click the device parts, copy, and right click and then copy, and 0.2 like this. You can see that new file that created in here. It is device graphene nano ribbon 0.2. You can see. Please follow that step. Result are still coming one by one. So you follow that step after the running whole project. I'm just telling how we can take different voltage value. When you selected the different files, copy and then created like this. You need to move that simulator parts, nanodecal, XCF calculations, simulator, nanodecal, XCF calculations. All the things will be same, but you need to move in the electrode tab. And like we are want to calculate for the 0.2, please select in here the that voltage. You need to select that type of value. After that, spin types, collinear spin. Sir is asking about, we have selected only that. We are not selecting any value in here. Just we selected that collinear spin by element, by atoms, and then you can click the generate files. Please ask anybody have confusion related to this. Now you need to follow that same steps. Click in here, simulator, nanodecal, analysis, device, left electrode, and you can select the charge and BK Patnaik sir is asking, sir, from where we get that electrode voltage? 1 minute, sir, I'm going to tell about. Generate files. You need to move the simulator, nanodecal, XCF calculations. In here, you can provide that electrode voltage. It user defined value you can choose for the left electrode, for the right electrode. If you don't want to provide in here that value, when you created that XCF input files, you can see, open with that value. System voltage of lead 1 0.1 for the left or minus 0.1 for the right. If you want to change, you can change. And atom that will be selected. All the setting will be same as previous. You can edit, it is user defined value. Now the same procedure, simulator, nanodecal, analysis, and device, right electrode, charge, generate files. Same for the device, nanodecal, analysis, device. You can select that the charge, I transmission, IV, like these properties, and simple moves toward these steps. Now,
Kindly give the scattering states.
okay, please move toward the simulator, nanodecal, analysis, scattering states. You can also select.
Yes, yes.
Right. Okay, and then please run that file. It will follow the same scripts. So you can select that type of value and open with. You need to see that the scripts, because it followed that scripts and then according to the run. In the nanodical, we have some dependency like charge, transmissions, or IV curve. It will come with the charge. So we need to follow some tutorial also. If the result are not come out crash, you can check in the open containing folder. In here, if the result are crash, you can check the reason why are they crash, and then you can correct your files and you can again run your files. Sometime it will be depend on the system or atoms. Uh, BK Patnaik sir is asked,
One question: Are this job will run in single processor? That I am saying because these are quite heavy jobs, heavy computation.
sir, your questions we have already replied in our first sessions. If it
Okay.
for the notes, we have already told it is a only session. And if you want to more notes or anything, you need to team with the sales. You need to
Okay.
talk with the sales teams. Okay. BK Patnaik sir is asking, sir, can we calculate impurity scatterings? Scattering of states, if you are choosing, sir, so you can choose that tab. But if you want to create in here the impurity or defect or doping, so you need to create another XCF file, sir. Like if you want to select that, 1 minute. If you are want to create defect in here like this and delete that atom, so now you can create again XCF files and then you can calculate different properties. So it one can be reason for the calculate of the scatterings that defect portions, and we can't tell about the calculate exact impurity scatterings in here, but it one of the regions, one of the way that you can calculate impurity scatterings. Like you can calculate defect, replace atoms. Like if you want to replace in here the aluminum, you can replace, and then you can move towards the simulator, nanodecal, and you can create the XCF files. After the running that XCF files, you can create another things. Okay, sir. We are we can calculate in here the 0.4, 0.6 with respect to the change the left electrode voltage and right electrode voltage. So like this, you can click the arrow and you can check, then you can again create 0.4, 0.6 at the same process, and you can create the long projects. I can only tell about how we can create, and it is still running because it will take times. Now many users want to ask that how we can create defect, how we can import another files. So like it is one of the regions, like if you are selecting that copy, and in here we can choose two just for the name, and then you can create like this. Now if you want to create in here the doping or anything else, Gopal Krishnan we are asking, signal integrity in device studio refer to the analysis and management of the quality of electrical signals within a device, especially a high speed application. It ensures that data transmission through a channel is reliably recovered, which is crucial for the proper device operation and preventing error. Device Studio, a tool from Teledyne, is used for making measurement and analyzing signal integrity. So just you are asking about the Device Studio and their analysis and management for the electrical signals. we can only simulate in here. No, not any softwares can give the exact 100% simulations results. We can only calculate in here that results. And so it is the just simulation softwares. We can work for the material and device parts. So you can create in here the defects like this. If you want to replace with the carbon or anything else, like you can again delete, and then you can replace with silicon. You can choose with another elements. You can visual that things like this. Then you can again move to the simulator tab, nano decay, accept calculations, and you can provide in here the new value, or it is user defined. If you want to edit, change or something, then you can simply click the generate files. So in here the created the new device structures files like this, and then you can analysis different properties in here, like if you are plotting the different characteristics, whole changement you can change, like many users work on the gas sensors. So you can directly move toward the build tab, molecule, and you can create different molecule like CO2, O2, and directly you can attach with in here. So you can absorb that material and you can simulate the gas sensors type of properties. So it is one of the examples that I can tell you. So I hope these steps and these examples we have completed in here. So anybody that wants to ask related to this examples, and so related to this example, please ask. Now we need to move far ahead with the different examples that we have.
Hello, the projected density of states corresponding to the transmission. That is to
Uh,
explain something, we require the projected density of states corresponding to transmission.
Projected density of states, you can also move toward the nanodecal and analysis parts. So
Okay.
so you can search in here that density of states, and local density of states is given in here, and different regions are given. If you selected the region, you need to provide that
Atom.
you can select the region or atoms points, and it is a user defined value, sir.
Actually, I am telling that for the DOS involved in transmission.
And that value you need to check in the MATLAB, sir. If you calculated in here, that's supported in the MATLAB. And
Okay.
PDOS is not. Okay, sir. Please unmute yourself. Too much sound is coming. So anybody ask related to this example, so please ask, and otherwise we are going to move ahead with different examples. Modulus of elasticity that we can calculate in here.
Hello, thermoelectric effect possible, that is Seebeck coefficient and thermal current.
I think you missed our previous session, sir. We saw the
Okay,
Seebeck coefficient effect, but if you want to see, I'm going to show you one of the thermal project also.
okay, okay.
Wait.
Kindly share the previous session recordings so I can see it then, Pierre.
Okay, okay, sir. Definitely. Please unmute, sir. Please unmute. Ah, too much sound is coming. Mute yourself, sir. When you speak, then unmute yourself. In here, you can see that material we have imported in here. And for the thermal properties, if you want to calculate, you need to calculate Hessian inputs. In the nanodecade tutorials, we need to calculate that parameters. Hessian delta, Hessian orders, you need to provide that input parameters. After that, you can select phonon band structure files like this. You can see. Then you can see that JT inputs that necessary for that files that you are talking about, sir. Conductance,
Yes, yes.
Seebeck coefficient, thermal conductivity for the phononic, and it for the different parameters that we have available. So we are showing in here. Okay, we have different examples, but you also need to follow the some tutorial file also, because if you have calculated one property, then you need to move the different properties, because we have some dependency of the some things, and it is a large theory part, so therefore it is difficult to elaborate all the examples in here, and it will take too much time. So I hope you understand how we can calculate this property. First, you need to define that material, or you need to import, and then you need to create the XCF input files from here, and then you need to analysis that Hexagon files, like analysis, Hexagon inputs, phonon band structures. Then you can calculate. After the completion, you can move toward that files. In the tutorial files, you can get a lot of the hints about these things, and then you can move toward that phonon density of states, and stress, anything that you want to calculate, and thermal electric properties also.
Sure, sure.
Okay. So now I'm going to also told about one of the more examples in here. So new projects. It also some dependency of the MATLAB. Here we can see the data of modulus of elasticity. First, you need to import materials like silicon, import local. You can see the different materials. You need to move 3D. And semiconductor, we're just considering simple value. We have that type of result, therefore we are selecting some selective value like silicon. Please select that value. If you want to redefine, you can also redefine through the build tab, but it will take times. If number of atom are increases, so its structure will also change. First, you need to generate XCF input files like this, XCF calculation. At the same settings, you can select, and it is a default value. If you want to change in here the value, you can change. Then you need to move the generate files. I hope everybody have completed these steps. If not completed, please ask. You can also see that script. So like this. After the create XCF files, you need to again move the nano decals and analysis plot, analysis tab. In here you can see modulus, van der Waal interactions. If you want to select, you can select, but you need to select that modulus of elasticity, that value, and you can choose that 0.02 and order you can select 2. BK Patnaik sir is asking, design a FET structure having GNR as a channel and SiO2 as a subtract. So tomorrow we will be explain about how we can create PN junctions. So it will be the tomorrow sessions. We will be explain about this type of structures. So please select that value. Then you need to click that modulus dot inputs and generate their files. You can also check their script. You need to through that files because XML files are necessary to have. You can also change that space grid numbers if you want to change, but it will be the same space grid numbers. Just explain about that your structure according to this arrangements. We follow the example portions only. Please run the xcf.input files. Please run the xcf.input files. Then also run that modulus.input files. I hope everybody have completed these steps. It You need to see this modulus.input files and their data in the large view. We need to open that MATLAB. If you want to see the graph, you can see in the device studio, but if you want to check their data value, you need to open MATLAB. It has the modulus.input file in the MATLAB form. You can check calculated result, elastic modulus. Like if you click in here the data, you can see that type of value. You can also check in here different value. So it is one of the way to import your value. How to get transmission.xml files. So we have already saw one year in our previous projects. So it for the modulus, and if you want to calculate in here the effective mass value, you can also use that tab or MATLAB. mm, Home device studio. That transmission.xml files are, you can see that data and result we have already, and their graph we can see in the device studio. So it is XML files for the transmission. Sir is asking, is it automated generated from device studio? Sir, it is data is automatic generated in the MATLAB, but for the transmission, we have already told how we can choose XCF files, left electrode, right electrode, then transmissions, analysis, charge, IV cut type of file find. But in the MATLAB, they are automatically generated when you import your projects. Okay. So related to this modulus of elasticity or anything is, please ask. uh, many of the users asking about the bending of the structure. In a previous session, we have already discussed about. So once again, you can also check bending of device. One side, both side, polarization angles, and psi angles. Like check their properties. You can bend that the same device structure preview, and you can check in here the XYZ, and then you can build like this, and then again you can move toward the simulator, nanodecal, accept calculations, and select that data. It is user defined, generate their files. Okay. We have also some types like multi-junctions. If you want to create interface builder, if you want to create, like in here you can see. Please move toward the build type and cat to atomic. You can open the device studio again, or if you want to create new projects, like you can choose cat to atomic tab, and like this build. First you can create one of the new projects, so it will be easy for you. New projects like this. So I can also explain about how we can use that multi-junction tab like this. Click in here and then paste and hold the mouse and you can create like this. Click that box, click in here and hold that mouse and move in here. You can create like this. Please follow. We have number of the video in the YouTube channel Impulse Technology. You can also visit that YouTube video of that channel's tutorials. We can explain about number of the tabs and things how we can use. You can explore a lot of the things in here. You can create like this. I hope everyone have completed this type of structure. Okay. Click in there the calculation tab and if you have created in here that any structures, you can directly import through that tab, but you are not created in here any. You can click the browse tabs. Did help to find stress, strain, and friction in the atoms, sir? Gopal Krishnan, they are asking. Sir, you can see in the analysis tab, stress and strain options are also available, but I am not too much aware about the friction. So we need, you can check in the MATLAB, and otherwise I am not aware about the frictions. Stress and strain you can see. Okay. You can import materials in the 3D, like simple material you can import, it will be easy for you. Like I'm imported in here the gold. You can import in here the different materials from your library. Like I'm imported from my library where your example are stored. You can import any materials, it's totally depend on you. You can import in here the copper type or any types. Like you can import in here the calcium. Please imports one by one. And the left and right you can import same materials, because if you want to create the device you need to select one of the symmetry. I think it is not, it's created in here. You can see you can change in here the stress if you want to choose like for your structures. Strain first surface, strain second surface, strain both surface according to your project, scale angles, ranges, like this. It taking some time to respond, like this. So I hope everyone have completed these steps. So we can build. If you want to delete, that option are also given. It is a default value and automatically selected. You can see AU, calcium, aluminum, silicon, and last site AU. Five type of structures we have, five type of elements we have taken. Preview, build. You can see it is built. It has been built. Then you can again redefine type if you want to do like this. Preview, like if you want to increase more and more distance. and you can choose that type of value. It's just one of the simple examples that we have considering preview and build. You can see in here the total number of atom 144. It is too much atoms in here, but if you want to change in here your structures like this, you can change, replace, change, delete. You can do simple. You can move in here the left electrode, right electrode, and click the preview options. Build. I hope everyone have completed these steps. So any confusion regarding this, please ask. Again, move to the nanodecals, accept calculation, basic setting, counter integral, electrode, iteration, then generate their files. When you run that files, you can move toward the simulator, nanodecal analysis, select that value, like density of states and another things that you want to select, effective potentials, and electron density potential that you are not completed, generate their files and run that files. So I hope everyone have completed these steps and you can do analysis like in your dependent projects. So anybody have confusion or anything that they want to ask, it is open to all. Please ask your query, and tomorrow we will be discuss about the some PN junctions, how we can calculate like silicon PN junctions and doping effects and how we can absorb that materials in graphene or carbons like gas sensor types. So please join the tomorrow sessions. Also, it will be helpful for you. So it is open to all. Please ask your query. Gopal Krishnanvi sir asking, it is possible to animation of electron move from conduction band to induction band. So, sir, generally we can't animate of the electron from conduction band to that induction type bonds, and we but you can see the post processions, and you can check the data MATLAB like band structures. We have the band structures or complex band structure type files, so we can't do animations in here. You can check that value. Okay. So okay. Now I'm going to end in here sessions. Nobody want to ask, I think, query, and if they have issue, so they can contact us, and you can also visit that Impulse Technology YouTube channels, and Nano Academics Technology are parent company and their tutorials. Device Studio also provide number of the tutorials. I'm Sahil Verma. You can contact us. So now I'm going to end here my sessions. Thank you very much for the join these sessions, and you can also ask anything if you want, and you can connect tomorrow also for the parent junctions type of sessions. So thank you very much.